we can just go ahead. So Navneet, you are not able to hear. Good morning, Lizzie. Good to see you back. Just a second, guys. Seems like there is a. Okay, wait. So today's this webinar is going to be an introduction, or rather than introduction, it is probably at some 20,000 feet level view of a very exciting thing that's called Spark, and so that Scala and Spark, what exactly is it, and all those aspects, right? So these are some of those exciting things which we are going to kind of just scratch the surface today, and for another 1 hour or so, and then we'll just take it forward. So still, by the time I have spoken, I mean, by the time I have started the webinar, up to now, within last couple of minutes, there have been, around some 40 more people who have joined. So I'm just trying to, let it to settle down a bit. Okay. Great. So I think, guys, it's good time to get started. So a very warm welcome to everybody on this open webinar on big data processing with Scala and Spark. My name is Vishal, and I'll introduce myself a bit about it. So guys, as you know, this session is going to give you a bit heads up about the upcoming course which we are going to launch very soon. It is going to be the combination of a programming language called Scala and an in-memory distributed processing system that's called Spark. As you already are hearing from me that there are so many people who are pouring in. Of course, in another 1 hour or so, I will definitely try to cover as many questions as possible, but again, since the number of people are too high, definitely answering one-on-one probably might not be possible. Just for the sake of it, we have created our own Twitter handle, that's @edureka.in, Edureka.in, and on Facebook you can say /Edureka.in, use #AskEdureka for the questions. So you can you can drop in your questions if just in case if they are not answered here. Also, I would highly encourage you guys to keep an eye on Edureka website as well for coming up for the latest updates on this side. So let us just get started with what we have for this session. Of course, as I can see, I can definitely see there are a lot of guys to whom I already know from previous batches. So before I introduce about myself, I'll just tell about the objectives of the session, and then we'll just get started. So some of you are already must have already attended Hadoop sessions and all. So definitely there would be that initial part, what exactly is big data, and the challenges might be a bit overlapping, but still for the people who are newcomers, it would be a very fast heads up about. Probably I think there is only one slide which we have kept only for this discussion. So what exactly is big data when we talk about it, and what are the challenges associated with it? And then the crux of the matter. What exactly is Spark? And so what exactly are its capabilities, or probably what exactly it is not, right? So we'll be talking about that. And then after knowing, okay, what exactly is this, we'll talk about why should we even go for Spark, because there are various other systems which are available. So we'll see that, we'll see about that. Then again, it is going to be a very, very high level overview of Spark ecosystem. Of course, there are quite a lot of details about each and every component, but still it is like, and also it is a WIP as well, work in progress. About many of those components, they are not even in their beta releases, they are still in alpha releases and all, which are like being tested by the respective developers by themselves. But still there is a lot of activity which is going on. And then after this, interestingly, if you see, the title of the course is Big Data Processing with Scala and Spark. So big data processing can be understood. Spark could be understood. But what about Scala, right? So what exactly is the role of it? So it's a brief note about Scala. Why Scala? And last but not the least, those people at least who have attended, just a second. Okay, so those people, okay, my PPT is gone. Is it visible now? Because I saw that there was a bit of disruption. That's great. That's great. Thank you. Just a second. Great. So now, yeah, I'm back about it. So last but not the least, as you already know that especially those people who have attended the classes earlier, they definitely know that our sessions are typically a good intermix of theory as well as the hands-on side. So even if this is a webinar, this is not going to be just the theory part of it, or just it's not a sales pitch which we are trying to put. We are just trying to show some of the capabilities. I'm not going into the installation and anything. It is just that I'll probably immediately launch a Spark shell kind of a window, and then would just try to do a bit of Hello Spark kind of a thing, right? So those are some of the things which we'll just try to get a feeling of it. What exactly does it take to let's say kind of create very simple kind of programs on Spark. So before so I hope we are all set about this entire coverage. Now before I proceed, typically people take the introduction as the starting part, but I have purposefully kept it after the objectives. The reason being that while I was talking about the objectives and all, which are clearly visible, there were so many people who were joining in. So guys, a little bit about myself. My name is Vishal Kumar, and I have around 10 years plus experience overall. And when it comes to the big data domain, I think last 4.5 years plus probably, I'm working in big data domain continuously. So when I started, like my journey started with Hadoop, and for quite a long time I have worked with that. Still I'm working with that, but over the period of time, needs or my exposure has gone from a batch analytics kind of a mode to a mixture of real-time analytics and batch analytics, typically those Lambda architectures and all, right? So that way I have explored a bit more about other technologies like Storm, and now actually we are working on Spark as well. So and apart from this, there are other frameworks as well, like there is something called SAMSA, some other NoSQL DBs like Redis, HBase. So these are some of those things which are the main components on which I have worked. When it comes to the functional domain side of it, so typically most of my exposure is towards the retail domain and a bit on banking as well, and there are some telecom clients also for whom I have worked. So I think let's keep my overall introduction up to this point. Let's just get started. Okay, there was some small, so please forgive me if I'm not able to answer all of your questions, but I just took a snapshot of it and I saw a question from Sushobhit Rajan, wherein he says that is it the open source Scala and Spark? Yes, they are open source. And great. Rajendra says my voice is a bit low. So is this so with everybody? Is it very faint? I hope it is quite okay, right? Great. Okay. Thank you. Thank you, guys. So Rajendra, seems like there might be some sort of speaker issue at your end. I would request you to please. But anyway, the recording also is going to be available. I saw a question regarding that also. So that is something which will I'll talk about that also at the last of the presentation. Apart from this, as I've again told at the start itself that if there are some of the queries which are not going to be answered, or which are probably I'm not able to answer them right away, these are the handles wherein you can, wherever you are comfortable, you can put in your queries. Also, there is a that sales number as well, wherein you can get further queries also. Okay, now let me just get started. So this is a the first thing first. I mean, why should even I come to learn Storm or Spark or Hadoop? Why? Because the problem statement for us is we are going to deal with big data. And specifically those people who have attended, let's say, Storm classes or Hadoop classes, definitely they would be aware that this is kind of, the first slide or the second slide which they typically see. And we have, clearly taken it from there from one of our batches. Now, the overall, so in that anyway, we have a bit more detailed discussions. But when it comes to, big data, what exactly is it? The simple answer for it would be the crisp and, simple answer for that would be, it just means a lot of data. When you talk about a lot of data, probably some years back when you used to hear from your, let's say, those RDBMS DBAs and all, they typically used to say if your database file size is, in the order of several GBs, 20 GB, 30 GB and all, you are dealing with quite a large database instance or big data instance and all. So that was the scale some years back. But nowadays, even I'm not talking at the scale of Facebook or Google and all, but typically the scale has moved towards the terabytes of scales, or at least hundreds of GBs of scale now. And this is a kind of a moving scale. Probably, 2 years down the line when people would be talking, there would be a session, something like that, on some new technology where probably people would be talking in several terabytes to petabytes of scale. So it's a kind of a moving scale, but it simply means that you are going to deal with a huge amount of the data. That is point one. But then, okay, so it means there is a huge amount of data though. So what exactly are the kind of challenges which we typically see with it? Of course, one challenge which we can easily see is it is the storage side of the problem, that it is going to be a huge amount of data. Yes, for sure. So of course, storage is a problem. Probably you are not able to store it in a single machine. But the storage part of it can be solved by storing it into multiple machines. But it is not just the storage which is causing us the problem. It is the crunching of the data also which causes the problem, right? So one factor of it is volume, and due to the volume, your space as well as when it comes to the crunching of it becomes a problem, right? It takes immensely long time. And then there is something called velocity of the data. So probably there are some good examples. Let's say, I typically give this example of a jet airliner, which typically, collects around 1 TB of data for every 30 minutes of flight. So volume is something which you already know, but when it comes to the speed at which you are, accumulating the data, that's typically called the velocity of the data, right? And again, this is quite high. 30 minutes, 1 terabyte. Assume that all the flights connecting all endpoints in the world every day, and then think every month, and then think every year, right? Huge amount of data. So it is not just the volume, it is the velocity as well at which you are collecting the data, or probably you might have to potentially crunch that data as well, right? So all of these points are going to form the base of further discussions which we are going to have. And last but not the least, it's about the variety of the data as well. So typically you talk about the RDBMS systems and all, you force a structure to the data. You say, this is the table wherein I'm going to store the data, this is the schema, this is the type of the data, and until and unless my data, from whatever channel it is coming in, it conforms to this specific format, I'm not going to store it, right? This is a typical RDBMS world. So, but when it comes to the non-RDBMS world or to the big data world, you are going to deal with a various variety of the data. It might be structured data if you are very, very lucky. It might be semi-structured data if you're not so lucky. But if you are out of luck, typically you might be, dealing with completely unstructured data, kind of probably pre-formatted text, probably it might be some sort of audio files, video files, it can be anything, sequence files altogether. So these are called typically 3 V's of big data, right? Your volume, the velocity, and the variety. So these are 3 different challenges which get associated with it. Of course, these are the 3 things which are summarized in the, kind of these 3 points which are shown on the slide. Okay, so I hope that that kind of, big data, what exactly is it, what exactly are the kind of challenges which are associated with it, at least for the guys who are attending it for the first time, who are even hearing kind of an explanation of big data term for the first time, might be finding it useful, right? And those guys who have already attended the courses, definitely they may find that, okay, it is an accurate revision, right? Correct? Now, so that was about just a primer about what exactly is big data. Now, when it comes to what is Spark, even before this, I would like to, even before covering any specific point about it, I would like to step back. And I would go one step back, and even before talking about what is Spark, I will talk about what is analytics. I mean, what exactly are the different kinds of analytics, right? So when I directly jump to the point of what is Spark, I assume a lot of things. I assume that you people know that big data, you are accumulating such a huge amount of data at such a rapid pace. Very good. For what purpose? You are going to typically use it for the analytics purpose. Okay, analytics. So typically, how many types of analytics are there? There are typically 2 kinds of analytics. One is the batch analytics, and second one is the real-time analytics. So when it comes to the batch analytics is probably kind of reports which you generate and which run at a specific frequency. That frequency could be once in a month, every day, every 1 hour, whatever. Right, so that is typically a batch analytics kind of a mode, and Hadoop is kind of best possible answer for that kind of requirement. But then there comes the second kind of requirement, wherein you are going to talk about the real-time analytics. Now, this real-time analytics is something which is quite challenging, which I would say is the bread earner for many of the companies which are working today on real-time analytics. So the typical example for that might be as simple as a bank. So you are doing a POS transaction, right? You are let's say swiping your credit card. Now there are 2 ways of looking at this transaction. There are 2 ways. One is a traditional way, right? So the traditional way of looking at the transaction is you are doing it, you kind of store the information. Let's say what is the customer ID, what exactly were the amount which has been transacted, whether it was a valid one or not, and so on and so forth. Now this is a traditional world where if you apply some certain checks and balances, if it is good, you are going to approve it and you are going to save it. Now let's tilt the situation a bit, and let's say you are going to have some sort of, now you're applying any kind of a big data solution and all, and wherein you are able to capture further more information. So typically, let's say I have started capturing in the geolocation. So latitude, longitude of the place from where the transaction has started, right? So just the moment I start doing this, then I'm going to have extra information. Very good. Now, let us say from a specific credit card, 2 transactions have happened. One transaction is happening right now. Everything looks good. Another transaction is happening half an hour later. Again, everything looks good. Everything is within limit. There are proper codes. There are proper authorizations which were provided. But there seems to be a bit irregularity. If I see, let's say the first transaction is happening in Mumbai, India. Okay. And half an hour later, I can see there is another transaction which is originating from, let's say, somewhere in Delhi, New Delhi. Now, with the geolocation, so everything apart from geolocations is good. but the geolocations are suggesting that within half an hour, if something is happening at these two complete disparate geographical locations, this might be an indication of a fraud transaction. Isn't it? Isn't it? In the banking terms, in a typical kind of a scenario, these two transactions don't raise any suspicion, right? But when you combine it with the extra information, whatever you are gathering, right, you are kind of getting overall different geographic locations altogether, right? And now the point is, if you are doing this check, you have to do this check when the transaction is happening. You cannot really do this check as soon as the transaction is passed through, or as soon as the payment has been done, because after that the damage, whatever had to happen, has already happened. You cannot stop it, right? So that analytics of the transaction has to happen when this particular thing was happening. This is just one example, guys. This is just one example here. There are so many examples which can be used. So now the point is, you cannot really know whether the first transaction was a fraud or the second transaction was a fraud, but definitely something has happened. So if you apply some sort of real-time analytics kind of solution on it, there is a bank which has already implemented. I was kind of helping them with it. I cannot really reveal the name of that bank right now, but yes. So due to this, what happens is, if they find this kind of disparity, you will immediately get a call. So this is kind of a referral system. Rather than directing it to the payment gateway, probably it would be redirected to a referral team, which will immediately call back the registered mobile number. They will confirm that there is a transaction at so and so place, and the other transaction is happening at so and so place. What do you think, right? And if the customer kind of identifies it with some sort of specific security questions and all, then they allow the transaction to go on. Otherwise, it is kind of cancelled, or it is kind of blocked. Isn't it one of the biggest examples? Of course, there are various kind of you can put various ifs and buts. What if I'm sending it via VPN, via US networks? Of course, there would be a lot of other things about it. But yes, the point is, you have taken a right step at the right time, right? So I hope, like, question from Ravish or Karthik and all, right? So, or probably from Varun, wherein you're saying, what if Mumbai transaction is fraud? So the point is, it's all about you are identifying it immediately as soon as it is happening, right, guys? So that was about that. That was so that whole point is, the idea of this example was to show you the importance of real-time analytics. Now I'll come back to Spark. So when it comes to the real-time analytics or near real-time kind of analytics, there are various solutions which are available. When it comes to this, then typically, I don't know if somebody has already attended the course on Storm. So Storm is another kind of a framework which typically, reads the streaming data, and then it keeps on performing calculations on that. It's a different model of performance. That is one. Spark is another one. Spark is more tightly integrated with Yarn, okay, or I would, rather than saying Yarn, with Hadoop. This actually comes from the family of it. So Spark, what exactly it is? Spark actually is a general purpose, and it's a in-memory computing system, and that too it's in a distributed manner. So if I put them together, it's basically a cluster in-memory computing system overall. So here, all of the calculations, whatever business logic has to happen, instead of happening it on the disk, it is going to happen in memory. And then there are several ways of caching the results and all, and then there are some refresh rates and all those stuff. These things do happen, but yes, it's all about that in-memory operations, as well as holding the results also in memory. That is point one. Second, it is so Spark is typically written in Scala. Nearly all of its source code is in Scala. So that's the reason you can easily see that there is a handle of Scala in it. But yes, having said that, Spark provides the APIs for Java as well as Python also right now. As of now, these three languages are supported: Java, Python, and Scala. However, for the obvious reasons, our entire coverage is going to be based on Scala, not on Java. Because one, Java is quite verbose. Second, Scala is much more beautiful. This is though it is my personal view, but still, that's how it is, and that's how it goes. Now, also, so this is one point. But is this the only thing which makes Spark very powerful or very popular? No. There are various high-level tools also which have been built very rapidly on the top of Spark. So there is something called Spark SQL. Sometimes people call it as Shark. There is something called MLlib, which is a kind of a machine learning library which is built on the top of Hadoop. So you can actually kind of correlate them to your Hadoop framework, wherein you typically talk about SQLs and all. Then you start thinking in the direction of Hive. Yes, you are correct when it comes to Hive, right? In Spark SQL, you can run all of your Hive queries as it is, unmodified, no syntax change. That is something which is the biggest gain. From the programmer's effort perspective, from a performance perspective, in some scenarios, personally, even I also have seen that the Hive queries run around 100 times faster. It is almost 100 times faster. So from the performance as well as development perspective, there is a huge, there are huge savings which are involved with it. So when it comes to Spark, of course, if I have to kind of recapitulate it, it's all about you get high-level APIs, you get high-level tools, and there are some more things which I'm going to cover now. Also, so when I cover it about what exactly is Spark, before I cover why Spark, there are kind of some interesting comments. So I believe Scala or Python is preferred over Java in Spark. Yes, definitely it is preferred over Java, because you can easily understand it, right? That it is all about so when it comes to Hadoop, you prefer Java. The reason being, it is written in Java, so there are some native dependencies and all which can easily be taken over, and of course there is a bit of performance improvement. But however, those people who have worked in Scala at any point of time, they know that Java and Scala are interoperable. You can call Java programs from Scala and vice versa, right? So typically people call Scala as improved Java. And as probably Karthik and there are some more people who are saying that how about Java 8? Definitely Java 8 is kind of trying to imitate Scala and nothing else. So there are some good things which are happening in Java 8, definitely. But the answer is you try Java 8, but the problem is, guys, one thing is for learning, right? Another thing is for the implementation in production. So typically those organizations and all, they have their environments already set up. So moving from Java 7 to Java 8, probably there are so many organizations which are not even working on Java 7 as of now. You're talking at Java 8 level, right? Which is brought in the concepts of lambdas and other stuff, right? So it will be a big decision. So it completely depends upon the kind of setup in which you are going to work, right? Karthik, others, right? So GC is asking about a kind of question wherein for real-time analytics, how to decide whether we should go for Storm or Spark. It's a very detailed discussion, GC. If I start answering that and the factors about it, probably it's going to be quite long. But yes, it's an interesting thing. You can follow some of the Edureka blogs about it. We'll definitely be putting something about it there, right? Okay, now let me just continue, guys. First of all, okay, there is this Lakshman. Lakshman, you are saying, can I speak loudly? So I hope I have checked it already 2-3 times. There seems to be some problem at your end, because others are able to hear me loud and clear. Right. So others are able to hear me loud and clear. Correct. In fact, I'm getting the responses like 200% clear. Great. So anyway, now without wasting any further time, let me just continue on the remaining thing. Okay, so there is okay, Lakshman, hi, you are back. So there, yes, I was talking about Spark probably some 3-4 months back, right? Wherein, okay, so I was referring to Lakshman Kaparthi, wherein he's saying, I remember Spark will be used for Mahout, right? And there is some progress. So some 3-4 months back when I was taking a data science batch, we were discussing it, and that time there were some tractions wherein people were talking about that now everything would be moved to something called Spark. And actually there is a huge this thing. So, February to July. It is official. It is, yes, it is kind of official, but it is not yet moved. Anyway, let's talk more about it later. So now after knowing what exactly is a Spark, when it comes to why Spark, right? So with Spark, you get a lot of flexibility. When I talk about flexibility, typically you go to any other, any presentation, be it Hadoop, be it Spark, be it Storm, you'll always see there is flexibility, and it's kind of their USP. It is no different with Spark as well. But the good thing is it provides you those options, right? One option is, hey, I want to just run my Spark cluster. I have Spark provides its own cluster manager, though it will be a admin kind of track, but still, it will provide you a cluster manager, wherein you can use its inbuilt cluster manager and go ahead with it. It would be a pure, simple machines and no Hadoop, nothing running on the top of it. Very good. There is something called Mesos, Apache Mesos, right? This is something which is a kind of another cluster manager, which is again does a similar kind of a things, but it is specifically designed only for cluster management. So you can deploy Spark using Apache Mesos as well. At the same time, you can you can run Spark on Hadoop cluster on the data which is there. Is staying in HDFS. So there are ways. So early that becomes the USP for Spark, that it is easily integrable with Hadoop. Now, I don't know if anybody has attended Storm classes or not, but when I took Storm classes, I used to get a lot of queries on that. Can't we integrate Storm with Yarn? And at that point of time, I told also, if you remember, that this is a WIP, work in progress kind of a thing. There is already a project which is going on, but it still is not completed. This is where Spark gains the edge over Storm, wherein it comes pre-integrated kind of thing. So if you talk about CDH5, Cloudera distribution of Hadoop 5, or you talk about HTTP, Hortonworks distribution, take any of these distribution, I think version 2.0 plus, they are providing Spark integrated. So the integration effort and other stuff are already taken care of. And with this, the good thing is you get the reliability of Hadoop as well as the speed of Spark. So it is all about the best of both of the worlds, which are which come together. So from the deployment perspective, it is you can deploy it in 3 different modes. That is another good thing. It gives you immense flexibility in the terms of the kind of implementation, whatever you want for, let's say, for your organization or for a specific client altogether. So by the way, we'll be covering like deployment using basically on Spark standalone as well as on Yarn also. So it would be a pretty simple thing. In course, we'll be covering that. Now, just continuing on the same thing, I think I have covered already this point, kind of at some earlier slide itself, wherein when it comes to why Spark, Spark framework is all about, it's polyglot, can be programmed in several programming languages. When I talk about in several programming languages, apart from Scala, Java and Python, nothing else is supported as of now, but it is like WIP. So probably, I don't know, some months down the line when you will see again this slide, probably you will see some more. You'll see some more options available to you. But as of now, it is going to be Scala, it is going to be Java and Python. probably when I'll show you some of the examples in the class. I mean, so the first batch, I think I'm going to take the first batch. At that point of time, when I would be dealing with some REPL thing, at that point of time I would be showing some of the most of my examples using Scala, some of the examples using Python, and probably one or two examples which I have kept for Java as well. But for all I think once I move away from REPL, when I go back to my actual codes and all, right, they would be typically in Scala only, for the very obvious reason, right, that because of the compatibility thing. Now, the same discussion continues when Hive. So typically people have seen a lot of potential that Spark does the processing in memory, and Hive, specifically those guys who are data analysts and all, they were very good with Hive. They said, we are able to explore the things very fast, which are there in SDFS, but not fast enough. Okay, it gives it Hive definitely hides the complexity of Hadoop from you. Definitely it hides. But the trade back is, or the trade-off here is that you are kind of going to get the answers in the orders of minutes, not in sub-seconds or seconds, right? So that was the problem with it. So once you combine Spark, okay, Spark along with the Hive, it is called Shark. So this is typically the word which it uses, and in some cases, I think I have talked about it. I have seen it performing almost 100 times faster. In fact, I'll show you. You know what is the what is the hello world of big data world? What is the hello world of big data? Hello world program, I would say. Word count, right? Right. You will see word count today also. You'll see the same word count, and then so I'm sure all those people who have typed word count, right? You must have attended Hadoop class, and you must have seen that typically you get some 10 or 15 words, right? 10 or 15 words, and then when you process it, it definitely takes easily more than 30 seconds or 35 seconds, right, guys? I hope at least those people who have started it, right? Now you will see what happens today. I will run one program for you, the same word count at the end of it, right? You'll see it today, right? So 100 times faster than MapReduce or 100 times faster than Hive, you can assume it as kind of interchangeable thing, Anil. Okay, so when you talk about Hive, yes, it is faster. We are comparing it with MapReduce, underlying MapReduce operations, right? Now, so let me just continue on something which is even more exciting. Okay, it's kind of recapitulation. So the good thing is that okay, just a second before I proceed, right? Before I proceed, there is one more important thing. So Shark, I have told you some of the advantages of Spark. There's another thing which is work in progress, which is not mentioned in this slide, but like with some of my friends who are already into this development, they are telling me about it. So just like Hive, you people would have heard about Pig, right? Pig. And people were working on with Pig. Basically, you were able to express your data flows much faster, much easier, right? Now, when it comes to, there are some efforts which are going on. They are not even in alpha release. They are still in development stage, guys. Okay, there are people who are trying to integrate Spark with Pig. Now, this is interesting. This is very, very interesting. Assume that the same Pig scripts, whatever you are running, start running 100 times faster. Isn't it a kind of a dream come true kind of a thing? At least to me it is. And that project, somehow I know that project. The name of the project is Spark, S-P-O-R-K, Spark. Okay, so it is, I don't know whether the project name will change over the period of time, but it is something like an internal project name as of now is called Spark. So let's see when it comes back, but yes, some exciting things are happening overall. Okay. Now, there are some questions wherein people say Impala is equally faster, but Impala has a different system requirements altogether. Anyway, now coming back to, so why Spark? So again, continuing the same discussion, wherein it provides you, caching as well as disk persistence capabilities. So you can perform some of the calculations. You can either keep them cached in memory, or just in case if the data is big enough, there might be some of the spells also which may happen, which you may allow. So there are various options which Spark provides you: memory only, memory and disk only. There are several caching capabilities which Spark provides you. The other good thing, which is really good about Spark, is it allows you interactive data analysis. When I talk about interactive data analysis, you talk about Pig, you talk about MapReduce. Okay, I'll not talk about Hive right now, but let's say talk about these two. You cannot really work interactively. You do not really have an interactive shell. With Pig, there is something called grunt. Yes, it is. But again, it is not purely interactive. But when it comes to Spark, it is kind of, it provides you REPL, right? Read, evaluate, process, and what is that? Load kind of thing, right? So this provides you that typical REPL feeling, and you can, write your commands, evaluate them then and there, and then see if they are working. And so, kind of easily interactive data analytics is something which is provided by it. Faster batch, no need to tell about it. Iterative algorithms. The biggest pain point for Hadoop is you cannot really support iterative iterative algorithms. So if you cannot really support it, so recursions, for example, right? Recursions and all are not supported there. But when it comes to Spark, yes, you can. Of course, there are ways, there are some tricks through which you can support it, but still. Okay. And third, last but not the least, so of course it is the, the outcome of first few 4 or 5 points, that all of those points combined together, they typically lead for, faster decision making altogether. So these are some of the USPs of Spark, which I would like to say. Now, this is something which is straightforward, okay? This is kind of a straightforward lift from GitHub. This is not from, this thing is not from Google Analytics. This is from GitHub. You can see the commits to, the master branch of Spark. So you can see this around October of 2013, and then 2014 start, and still it is going on, right? There is huge traction in the number of commits which are happening, and the community is super active. There is one thing is called active, there is something called super active. By the way, another important thing, Spark got introduced to Apache community later than Storm. Okay, Storm is an incubator project. Spark has become a top-level project. Spark has become a top-level project. It is the first project, or I would say the project which has achieved the top-level status in the record time. So this is another the kind of exciting thing which is coming up, and there are already companies like Uyala, you talk about, I mean there are several others which are already using Spark and Storm parallelly in their production systems. So I mean data speaks for itself, so rather than talking much about it, I will leave it to your analysis itself. Now, it's kind of Spark ecosystem, wherein you must have heard about Hadoop ecosystem when we were talking about Hadoop, but right now we are talking about something called Spark ecosystem. Now this is something which is, you can see that there are some of the points which are, you can see that alpha release, actually there is a spelling mistake here, it's actually alpha or pre-alpha release. So you can see this BlindDB, graphics, SparkR, even mlib also. It is mlib. There is a very, I mean, there are very few capabilities, or there are very few algorithms which are supported as of now. But again, the count is continuously increasing over the period of time. But right now you can see actually there are 3 colors: Shark, Spark Streaming, mlib, graphics, SparkR, BlindDB. They are built on the top of Spark core engine. I will cover them I'll immediately try to cover them in bit more detail in this slide. So first of all, Spark core engine is, as you can know, that it's all about writing your raw Spark program, write your Scala program, launch it, write your Java program and launch it, and so all of that is being executed by Spark core engine. But then when it comes on the top of it, there are various projects which have come up so fast. One is Shark. I have already told it's about if you have to do some sort of structured data analysis, Spark, and of course your volume is too much, then typically you would like to go for Shark. On the top of it, you can see there is something called BlindDB. Now, as a name is quite interesting, isn't it? Blind database kind of thing. It is approximate SQL. Now, this is something interesting, isn't it, guys? Especially those SQL guys and all. Approximate SQL. What does it mean? It means, see guys, I am getting a barrage of data. I am getting huge amount of data. So I'm not really interested in exactitude. I'm not really interested in exact results, but I just want to get a feel of it. I just want to get an approximate results. So fire a query, do some sort of sampling, give me some output. So that is called approximate SQL. Isn't it a new and interesting concept? Many times I don't really require accurate result. A sampling would do for me, isn't it? So it's kind of BlindDB, which is still WIP, but yes, it is one of the very exciting features to watch for. So of course, in the coverage also, I'll talk about the coverage a bit later. Of course, we'll not be able to cover SparkR or BlindDB or even for that matter mlib also or graphics because they are not yet released. But we know that yes, these are some of the WIP things, right? Which will come over the period of time, right? So now, let me just go forward. Okay, so Kunal says Shark is for structured data analysis. Okay, guys, so I'll take your questions a bit later. Let me just complete some of the things here. Okay, so now when it comes to Shark streaming is all about, this is where Spark takes the power or takes the role of, or I would say potentially can take the role of Storm, wherein it will enable you to do the to create the interactive applications using the live streaming data. You can do the streaming of the data, and then Spark can read that, can run its operations from the streamed data itself. So that is about Spark streaming. And then there is a machine learning library. It is just like Mahout, which is built on the top of Spark, but only thing is it runs almost 100 times faster. It is not yet so enriched as Mahout. Let me tell, it is not yet so much enriched as Mahout, but yes, it is coming up well. And then just like you talk about graph processing, then you have Neo4j, you have the options of Giraffe and all for distributed graph processing and all. But when it comes to Spark is trying to create something on those lines as well. When it comes to that, it's called Graphics or SparkR. There are so many people, especially from data science track, they must be aware R is like for statistical analysis. Definitely, it is something which is very exciting. And already there is an integration for R with Hadoop, which is already existing, right? So R with Hadoop, definitely it is there, but now there are people are now but again, if you remember, R with Hadoop is a kind of a accidental project, I would say. So R was being developed, Hadoop was being developed separately, and then there were some attempts to create it, and CDH 4.4 onwards only now you are having that kind of integration already available. But with Spark, all of these things are being taken care from the very start itself. So whenever you will see a release of it, of course, that kind of installation issues, I specifically remember with some of those data science guys, it's not only they, it's we who have, struggled quite a lot in doing that R and Hadoop integration and making some of the things work. So hopefully when it will come up, at least those issues should not arrive with Spark. So that is about Spark R, and this is how the Spark ecosystem would look like. I hope it excites you quite a bit, right? So that was pretty much about what exactly is Spark, what exactly is its ecosystem, why should I go about it. Now a note on Scala, but before that I'm just trying to sample some of the questions and see if I can answer them. Atul says, hi Vishal, I'm more interested in reporting requirements on big data. Are the tools on Spark and Storm can also fulfill it? If not, what are the typical reporting tools? Okay, so all I'll say is, Atul, typical reporting tools for big data world, you can explore something called Platfora, you can explore something called ClickView, you can explore something called DataMeer and all. So there are typical big data world this thing, but however there are capabilities through which you can feed the data back to the traditional reporting systems. Okay, however, when it comes to Spark and Storm, fulfilling the reporting requirements, this is not a valid question. They are from the crunching side, they are not from the reporting side. I hope I have answered your question in very fast and to the point manner, right? Great. Why did Spark choose Scala over Java? Okay, Scala is called improved Java, and typically I also don't like Java so much. My personal, if you ask me personally, I like Scala and Ruby and a bit of Python. So it is brevity of your your language. The same thing, if I have to say, I would like to say in 2 lines rather than saying the same thing in 10 lines, right? So that's the advantage. And in fact, if you see Java 8, it is trying to imitate Scala. There are some examples wherein you'll see you cannot really recognize unless you know what is the name of file, whether it is a Scala code or a Java code, right? So no, it's not like I don't like Java. I don't like Java when it comes if I have the option for Scala. That's how it is. Okay, Tarak. Okay, so now coming back quickly, so a note on Scala. The good thing with Scala is the pure object-oriented language with the support for functional programming. Isn't it something, at least to me, it looks very exciting. It looks very exciting. So it is a pure object-oriented programming language. Everything is an object, but it gives you the support for functional programming, which typically, if you, I don't know how many of you have developed the systems for big data in production, but if you have, then you must be knowing that when it comes to the big data systems and all, typically object-oriented programming and all take a backseat. Typically, your style of programming is more of a functional thing, right? That's the reason typically people go for Hadoop streaming rather than going for native MapReduce, unless it becomes absolutely necessary, right? So those are some of the things which are very, very exciting about it. It supports both, both kind of, both kind of programming styles altogether, right? So that is one thing. And of course, Scala is very much in the fabric of present and future big data frameworks. So I think I saw a question earlier, but I could not answer it, wherein somebody was saying that can I write, MapReduce programs also in Scala? Definitely you can write MapReduce programs in Scala. However, there is already a framework, Scalding, through which you can write your MapReduce jobs much more easier in Scala. So Scalding, it's there. Spark, talk about it. You talk about, so rather than this, what I can suggest is go and type something called Spark, and then you can see what exactly is, are the, oh, okay. So type Apache Spark, because if you type Spark, you'll get a lot of variety of links, right? But when you type Apache Spark, you'll see what exactly are the exciting things which are happening in it. So of course, it is the part of it. Akka is a different ball game altogether. Probably you will see some type of course being launched in Akka also. I kind of had to work on Akka some time back, but again, that guy has also completely written Scala, right? In fact, Akka works on a actor model of Scala altogether. It is kind of enhanced. And also kind of a note which you are seeing that all of the examples of Spark which you will be seeing for all practical purposes, they would be in Scala. They would not be in any other language. And we understand that when it happens to Hadoop courses, so when it comes to Hadoop, Hadoop is quite a big framework. It is much bigger, at least today. It is much bigger as compared to Storm. Storm is a very, very small, I would say, not even 1/5 of Hadoop, and framework like Spark, which is still evolving. But yes, like early adoption is there in industry. That's why people are asking for it, and that's why we are launching the course also for it. But yes, Java is a prerequisite, and many a times people do not have the background of it. We have received many feedbacks from people that there should have been a specific session for Java, but we have purposefully not taken any sessions separately. We have provided some self-paced courses wherein people can go by themselves for the required knowledge of Java, but we can afford, as of now, we can afford to have a separate sessions, about Scala. So enough Scala coverage would be there in the course. This is the right time when I talk about it. So in fact, the entire course is going to be 8 modules. The first 4 modules are completely on Scala, and the remaining 4 modules are completely on Spark. So before, it should not happen that when I'm talking something about Spark and trying to write something, you are just wondering about the syntax. You're just wondering about what exactly is it. Is it an object? Is it a, kind of this guy is trying to write a for loop, or is it, because the syntaxes are way different from Java. The traditional Java, whatever you have seen. So with Java, because there might be a lot of people who are already working in it, but definitely our experience is, at least on these newer set of technologies or newer set of languages like Scala, like Python, Ruby and all, or Haskell or Closure and all, people have not really that much experience. So it makes a strong case for us to do the coverage of Scala, at least enough coverage. So we are not going to do a complete reference of Scala here, but in 4 modules, I think approximate 12 hours of it are going to be dedicated to it. It will be enough for you to get up and running and explore more things on your own. So that's where I hope the name also is quite clear to you, right? Would you cover actor part? No, not necessarily, Harsh, because actors is something which will take you to the direction of Akka. So there is a separate course on which not only I, there are other people also who are working on it. Okay, so at that point of time, definitely we'll be covering those actors part of Scala. But with this question, I assume that you have some background in Scala already, right? So that's a good thing. And the other good thing about Scala is at least in order to understand it, you should know at least programming. Because when I would be covering it, I would not be telling you what exactly is a for loop or what exactly is a while loop. I would be covering it from the angle that how exactly it is implemented in Scala, right? So for loop, while loop, if else, kind of, there are no case statements in Scala, but yes, what are the options, iterations, collections, at least this basic understanding should be there. We'll see how to, how exactly Scala is different from other languages. So per se, you don't really need to know Java, you don't really need to know Scala, but you should know programming. That at least this is a fair assumption, right? So that would be about Scala coverage. Why Scala is something which I have kind of already covered, right? So this is something which you can just have a look of it. There is absolutely nothing new here. Now just moving to the next slide, which is going to be Hello Spark, and after that it would be like end of it. And I think, yeah, we are pretty much on time. It was kind of 1 hour session which we planned. So okay, there are some questions like very quick question: what is the best combination in sense of carrier? Scala, Spark, Hive, Peg, Hadoop? Okay, so Srini, it's a very open-ended question, and I would say, I mean, it just depends upon the kind of exposure which you are already having versus whatever you are going to have or planning to have. So typically, if you're going for a batch analytics kind of a exposure, then of course Hadoop and all are good for you. You don't even need to move to Spark or probably Storm or something else. But just in case, but again, the world is not fair, right? You do something, then they ask for something more. Then of course you might need. At least it is good to know what exactly are the capabilities, right? Can Spark be used for transaction processing as opposed to the analytical processing? Not really, as of now. As of now, not really. But at the same time, with streaming, yes, potentially you can generate it. Because see, what is it? You're writing a Scala program. And what is a Scala program? It's just like a Java program altogether, right? So, and if you are reading the data from streaming and on the fly you have to perform a transaction via JDBC, can't you do it? Definitely you can do it, right? This was a question from A. Chattopadhyay. Looks as big data professional, we need to keep learning all the time in life like Java. So Tarak, this guy, Vishal, I mean myself, I'm kind of learning it since almost like almost more than 5 years or something. And still, I hardly know 5% of it. Anyway, now let us just go immediately. So how Spark is able to achieve faster speeds in memory processing? Anil, I think I gave the hint about it, right? You will get more hints about it now. Okay, just let me flip from it. And so what I get from it, Spark related to batch and Storm related to live processing, live stream. Harsh, you have seen it, right? That when it comes to the Spark streaming also, you can actually replace Storm. There. So Storm would be working in a completely different manner. Right. Now let me just quickly go. So guys, I have this my machine up, my virtual machine up, but since the display is something like not such a great one, what I have done is my virtual machine is there on my machine, and via putty I have connected to it. So let me just clear it out. So here I have kind of already installed Spark. And I'm not going to tell you how to start Spark, how to do this. All of that is something which I'm not trying to cover right now. What I'm trying to cover here is kind of just to give you a feel that the same word count example, right? The same word count example which you saw, if I have to run in Spark, how exactly, how good it would look like, or how fast you can perform it. Okay, so this is something which I'm planning to show you. Amitabh says, do we need to learn Hadoop if we know Spark? See, again, Amitabh, you can run Spark in various manners, right? If you're planning to integrate it with Hadoop, it's good if you can know Hadoop. Or otherwise, if you just know how to fetch the data from Hadoop and then submit it, that's enough. Amitabh? Right? Great. So, okay, there are some requests for increasing the font size. Just a second, guys. Oops. Please help me with it. I typically don't use it. Change settings. Change settings, and then I'll go to appearance, font. I would say, let's say 14 would be good. Apply. Looks good? Looks good to you guys? Great. Something to volume moves. Rajendra, I'm not really sure because, you know, guys, are you all able to hear me properly? I don't know. I have seen some three, you know, points wherein people have said that they are not able to hear me. And there are almost, yeah, there are more than 250 people right now. Great. Great. Sure. Thank you. Thank you. So Rajendra, I think you need to just probably check it. Otherwise, you know, after this, we are going to upload the recording also. We are going to upload the recording as well. So recording as well as this PPT, probably this was a question from Lizzie or Subha Reddy or somewhere. I think Subha was there in yesterday's session also. Yesterday I took a session for Storm. So yes, you guys, you know, you will be getting it. So we'll be uploading it in Edureka blogs and all. Yes, definitely. This PPT and everything would be uploaded. Don't worry. Okay. So now let me just get started with it quickly. So now I have installed already Spark. So I'm going to cd Spark 1.0.1. This is the latest version, though I think I would be covering 1.0.0 in the class. But anyway, now I would say when Spark shell, this is like your fastest way of invoking Spark. And you can see that your Spark thing comes up. It basically, if you're seeing this, and the next thing would be this. So this is the biggest proof that Scala is the main guy. So by default, your Scala, this thing will start. Though, if you want to test it out, let's say instead of Scala, you want to test it out in Python. There is something called PySpark. Okay, there's something called PySpark. PySpark would be, you know, opening it. I will be covering some of those things in the class as well. How to invoke PySpark instead of Spark shell, and what exactly is the, you know, are the pre-steps which are required for you to come up to this stage, right? So anyway, for now, just assume that yes, somebody has installed Scala, Spark, and it is up and running for you. Now, how exactly to go about it? An interesting question wherein somebody has said that, you know, is Spark only compatible in Linux-based systems? You can definitely install it in Windows as well, but again, recommendation would be Linux-based systems. So right? Okay. Now, so we are into the REPL. Now, I've just kind of, you know, created some small examples for you. So there is enough of Scala which is going on, but let me just kind of, you know, try to put it. So guys, this is val nums 1 to 10,000. Essentially, I'm creating a range here. Okay, actually 1 to 100,000. 1 to 100,000, it's just a range. When I say val nums, it is, when I press enter, it just has created a collection. Okay, and fortunately, it is not typing everything, right? So it just gives you 170 and dot, 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 dot. It just says that, hey guys, you know, I've just created a range here. Okay. Now, once you create the range, this is where the magic of, this is where I would say the magic of Scala, or I would say Spark, comes into picture. Okay. Now, see this, val dist data is equal to sc.parallelize. So if you see, nums is something which I created and parallelize. Before this, see this, Spark context available as sc. Spark context is available as an sc variable here. When you will be writing your own programs, you will be creating a separate Spark context object. But here, when it comes to you know, Scala, it comes inbuilt to you. Spark shell, it comes inbuilt to you. Okay, so this is where you have kind of, you're just saying, hey, I want to parallelize it. There are various other options also wherein you can actually specify what is the level of parallelization you want. Here I'm working on a simple machine, so I'm not even giving that option. But yes, you can say parallel of 3, parallel of 4, parallel of some another, you know, kind of factor, whatever you want. So this time I've said st.parallelize, parallelize nums. When I press enter, it just does nothing. It just does nothing. So this is where this is parallelize. Parallelize is all about that this particular data set is now parallelized to various threads or various machines which are there in your system. But for now, assume that they when I talk about a single machine, it will all be about parallelizing it in the threads. Okay. Typically, this technique you will not be using in a distributed environment system. This is just to give you wherein I am injecting some data by myself. Typically, you would like to read the data from somewhere, right? So anyway, never mind that. We'll be covering that a bit later. But now, a strange thing has happened. When I said, well, nums 1 to 10, 100,000, it just created something. When I said parallelize, then it just said, it just gave you a bit description about it, that parallel collection RDD. RDD is a kind of heart of Spark. I'm not covering all of these things in detail, guys. I'm not covering all of these things in detail, but it is all about RDD stands for Resilient Distributed Data Sets. Okay, so what exactly is it? It's like this data set would be available to all of the machines. Anyway, how exactly and what would be the scenarios behind it, we'll cover later. But the point here is, the moment you said parallelize, it didn't do, because it follows something called lazy operations. Okay, so until and unless, so there are two kinds of things, transformations and actions. All of the transformations are lazy. They're kind of calculated, a graph is calculated, but they are not really acted upon until and unless you force an action. So whatever I did was a kind of a transformation. Now this is an action which I'm trying to do. So I can easily understand that this is kind of alien syntax, especially for those Java people, right? So what I'm trying to do is dist data wherein I parallelize it, I'm applying dot filter underscore. Underscore stands for, it's like wildcard star. Okay, anything which is less than 25, collect. Okay, now when I say collect is like putting them together, okay, in a single list all together. And when I press enter, see this. It was a simple program wherein I had created 100,000 numbers. Out of that, I just did a filter. If you are aware of pig, what was this operation? This operation was about do load and do a filter, right? So filter is using a closer. Yes, Harsh, it is definitely using a closer. So everything, whatever you are seeing under this is a Scala code, right? Right? So guys, isn't it interesting that if now I'm sure if you remember, if you have to write your own pig script and then try to run it, how much time would it take versus whatever time it took on the same machine, same configuration? You can try it on your own, right? So this is one thing. This is one thing. Try to run pig on local mode as well. Now, see this. Try second time. Even faster. Even faster. Right? Anyway, let me just not go much detail into this. Okay, there is a word count example. I try to keep two different flavors of it, but I would like to go for the third flavor. I mean, to the second flavor of it, just because of the time constraints as well. Let me just show you something here. Okay, so let me come out of it. Exit. Clear. This is ls. There is a file, typically readme.md. If I say key cat of readme, just a second guys, .md, and I say head, you'll see some of the documentations all together, right? So the best place is, this is a pre-formatted kind of a text and something like that. Now this is the right time to perform a word count on this file itself. So this is what is it all about. So what I'm trying to say is, the first example you have seen wherein I have injected some data by myself. This is the example wherein you are seeing I'm reading the data from a particular file. So I'm saying val IP underscore cached, okay, is equal to Spark context dot text file, and within the text file I'm just applying the location of the file right now. So that's it. Okay, sorry, I'm sorry. I have to again invoke Spark shell. So I did it just to show you that, yes, in case if you are worried that what is happening behind the scenes, right? Come on, get fired up. Great. Now, so I've said this, and IP underscore cached does not have any meaning. It could be Vishal, it could be, you know, Gopa or anybody for that matter, right? So it just created it and that's it. It is just keeping silent as of now. Okay. Now, see this. Val w is equal to input cache dot flat map. Flat map, you are aware, but when it comes to flat map, it's kind of list of maps or list of lists, just in case if you know people were not aware of it. So what I'm trying to do is I'm trying to take the line of it and then splitting it by space. Guys, you remember word count? I'm sure at least those guys who have attended my classes can easily correlate to it. Others also, but you know, I typically spend a lot of time in that, right? So Satyam, yes, I can definitely be faster, but please understand that there are some more people, you know, who might be new to this, right? So I have to give some time to them as well. Okay. Now, split by space, and then I'm applying a simple map site wherein I'm saying dot map word word, and word is herein I'm just saying word comma 1, right? So it might be looking like a spaghetti code to you. Please do not worry about it right now. It's like I'm applying collections and on the top of it I'm applying a lot of lambdas here. Okay, but it is all about this, just in case, just try to understand that this is a kind of your mapper phase, and then something interesting is happening. I'm saying dot cache, right? This is where I'm putting it in memory. This is where I'm putting it into the memory, and once I do this, then I'll say w dot reduce by key, you know, star, basically underscore plus underscore. It's all about you know, star, underscore stands for star, dot collect dot for each println. So a lot of things. Please do not worry about syntax. At the end of the day, I'm going to apply a mapper and a reducer, and then finally I'm going to just print it out. Okay. In the previous example, I was doing the exact same thing, but I was saving the data into a file. Guys, right? Guys, I hope you are able to see both of the things, right? And the difference was there I was not doing a caching. Here I am doing a caching. That's the only difference between these two codes. Are you all able to see that? Could you please confirm? At least not all. Some of you could confirm. Right? So that's the only difference, and due to which I have taken the third example. That the first one I was persisting it in the hard disk. In this case, I'm not persisting it. I'm persisting it in memory. Okay. So let me just quickly do this. I think I have read it. Very good. Now let me just fire up the second one and show you something. When I press enter, see this, nothing has happened. Though I have invoked a code here. I have invoked a code, but nothing has happened as of now. Okay. Now let me apply an action. See, if you remember collect or for each println, that is action. Yes, lazy transformations. Exactly, Amitabh. Okay. Now it's like the same thing of pig. Okay. Now reduce key dot collect dot for each println. Now see this. What will happen? Ran. Quick, fast. Word count. I'm not going to confirm word count and all here, but see this. Right, guys? Two lines of for word count program. See, 2 lines of word count program is fine. Run the very same program in Hadoop. Run the very same program in Hadoop, right? Guys, I hope you are able to recognize it. Can I get a confirmation? Have you seen how fast it ran versus whatever speed you were getting? No. Now the story is not over. The story is not over here. So if you are seeing it will take more than 30 seconds in Hadoop and it ran so fast here, the story starts now. See this now. What will happen now? I am firing it again. And see what will happen. Even faster. Because I have cached it. First time it took a slightly longer time, right? For the first time, but it was still much faster than Hadoop. From second time onwards, it was even faster by its own standards, right? Have you seen this? Right? Exactly, RAM is costlier than this, definitely, but yes, the prices are definitely, so there is always going to be a trade-off kind of a thing, but yes. Right? So how is the cache cleared? There are forceful ways of clearing the cache or re-evaluating an action. There are some of the things, Lakshman, I mean, which probably it's not really the right time to discuss all those things, but yes, there are ways to clear the cache. Either you reevaluate your action or you forcefully clear the cache. Right. So there might be a lot of new questions which might come up. Hey, you are putting the data in memory, fine. But at what stage should you put the data? That is also very important, right? How much data do you want to keep in memory? And what if your memory becomes full, right? So whether the spill should happen, spill should not happen, or should you never keep the data in memory, or whatever, right? So there might be various kind of things which will come, and of course Spark answers for it. It provides you various options the way you want to arrange your data. It gives you that full flexibility. Right? Input split file is right now on the local file system. If I would have integrated it with Yarn, I could have put this file in SDFS and it would have fetched the files from there and run it. Isn't it interesting? At least to me it looks interesting. That's where in fact my journey to Spark started. Probably I think not even a year, some months back. Okay, right, Tarak, you're right. So guys, I hope you liked this session. And I think with this, the session also comes to an end. Right, Satyam, I hope how is out of memory managed? I hope you got the answer for this, that it provides you the options, right? So this is where I end the session, and just in case, I hope there might be some of the people who would be up very late in US. I appreciate your time and effort which you have put. Thanks a lot for attending the session. I hope it adds some value. As far as it adds some value, adding some more time is worth it. Sure. Thank you guys, and can see you there later. Okay. Okay then. Sure. I'm now logging off. Okay. Bye. And do drop in your queries at our Twitter handle. We'll definitely be responding back.